What you just saw is a furnace room with 20 temperature sensors across 3 zones. And the moment one sensor in zone C started climbing out of range, this system caught it instantly, flagged it on the dashboard, and then the evidence was already in database before anyone at the workstation had ever noticed. This is exactly what we are going to build together in this video. To bring this to the life, we are using real ESP32 and DS18B20 temperature sensor, while simultaneously running 19 software simulated sensors in parallel using hardware in the loop testing. With this entire 20 sensor network publishing data every single second, we are generating 1200 data points every minute, which adds up to over 1.5 million rows of data in a single day. Because of that massive volume, I used Tiger Cloud's managed TimescaleDB for this project. So it can hold that relentless time series workload easily, swallowing those millions of rows without need of any manual configuration. Finally, we tie it all together with live Grafana dashboard that constantly watches the stream, catches the breaches, and flips the alert panels the exact second a threshold is crossed. To accelerate the development of this entire stack, I actually co-piloted the project with AI assistants like Claude, using them to rapidly generate our backend code and complex Grafana dashboard configurations. So watch until the end for all the AI prompts and outputs generated in this project. Hello everyone, I am Hariharnath and welcome to IoT Frontier. The ESP32 reads temperature from DS18B20 sensor and publishes it over MQTT to a broker. The simulation engine does the same for 19 virtual sensors, all on the same broker. A Python subscriber sits in the middle, picks up every message from all the 20 feeds and writes the data in Tiger Cloud. And Grafana connects to Tiger Cloud, visualizes the data in real time. When the sensor breaches the threshold, the alert is shown on Grafana dashboard. Now we'll wire the DS18B20 to the ESP32 using this circuit diagram. First, we'll try to set up the Arduino IDE. So we'll open this Arduino IDE and we'll go to the preferences and check you have this ESP32 JSON is available, and then you need to enable ESP32 board from here, and after that go to library manager, and so you need to install these 4 libraries. Now is the part where we use this AI coding using Claude so that we create this firmware quickly. So I just open the Claude and create a new chat and type a prompt. So here you can see I am asking for Arduino firmware for ESP32 with the details of which GPIO you have used, etc. and what are the different libraries I want to use, and then within few seconds I'll get an output. So I'll be using this code onto the Arduino IDE, and the few things that you need to change is the SSID and password of your Wi-Fi, and the MQTT server. This is from the IP config. I'll find the IP address of my laptop, and this I can put it because I'm connecting and running this MQTT server on my laptop, and ESP32 will be running this code, and the port is similar and remaining all are same. So here from the code we are running as a sensor 1 from zone A. So it will start reading temperature data from the sensor and posting to the MQTT. So once the code is done, you need to select the hardware and the COM port and then upload it. So in the meanwhile, we can start downloading the Mosquitto. So this is the Mosquitto MQTT broker, and you can download for Windows or any operating system and start running it. So once we download, it will be available in Windows in this path. So I'll just cd into it. There are few things that you need to change is you need to create a config file. Here allow anonymous, we have to make it as true, and then we need to search for listener. So here 1883 port has to be enabled, and once that is done, so using this command you can start Mosquitto. So my Mosquitto is already running, so that's why another instance will not be running. So in the meanwhile, you also need to allow the inbound rule of 1883. So because you are using ESP32 and the data has to come to your laptop, that is inbound to the laptop in 1883 port. So for that, we need to allow it. So by default, it will be blocked. So you need to go to advanced settings in Defender Firewall, and here you need to click on inbound rule create a new rule. So here type port and click on next. What is the port that you want to use? 1883 TCP, and click on next, allow, next, and give a name and complete it. So I have already done it. So I'll just close this. So in the meanwhile, we'll see the serial monitor of the physical sensor. So you can see that the data which is being published continuously. Now that the physical sensor is done, we'll look into the 19 simulation sensors and how we create with Python engine. We use Claude to create. So here we need to just mention it, the important details, like we are going to create 3 zones which has 6 sensors here, which will be the baseline of 75 degrees Celsius, 7 sensors in zone B, and the baseline 82 degrees, zone C of this much of temperature. So this is all physics. So every zone has a baseline temperature, and on top of that there is a slow random drift that is shared across all sensors in this zone, which means all 6 zone A sensors drift together. This is what real correlated sensor clusters look like in a furnace environment. And then each sensor has its own small random noise on top of all that. And then we inject the anomaly, which is at t plus 90 seconds. That is completely deterministic and gives you the same ramp every single time, which is exactly what you need when trying to create this tutorial. So it has already generated a code for me. I'll first create a directory. So this is the directory I have already created. Then we'll get into that directory and we'll enable the virtual environment, activate it, and then install the important Python libraries. So here Python MQTT and PSYCOPG2, which is for Postgres, and python.environment for loading the environment files. So this is already requirement satisfied. So we'll just open simulation engine with VS Code. So with this command, the VS Code simulation engine is opened, and I have already pasted the code, and here you can simply see the broker we are using localhost. The simulation is explained here. So zone A baseline this much value, zone C this much value, and what is the anomaly sensor? Here we see the sensor 17 from zone C is going to drift away from the normal ranges, and where we can see the anomaly. Before we run this, we have to look into MQTT Explorer. So we'll open the MQTT Explorer so that we can verify the data. So here I'll just create a MQTT local broker with this host, that is my laptop. And then in the advanced settings, I'll just create a new topic. So this topic is factory/hash, which means it is a wildcard. After factory, whatever the data is coming, we'll just look into, because so if you see, the topic that we are going to publish is like this: factory/zone, whether it is ABC and sensor ID. So that's why we are using wildcard to run this. So you can connect to this, and first you will be able to see only one sensor that is from your real hardware. So that is continuously changing. So now if we start running the simulation sensor using Python simulation engine.py. So now after this, you should be seeing all values coming in all zones. So you can see zone A has these 7 sensors, and then we have these sensors which are all simulated. So all simulated values are coming together, and the real sensor value is coming at a different interval. Now let's talk about where all of this data is going to live. So that is database layer. So 20 sensor publishing once per second, which adds up to 1.73 million rows every single day. If you try to put that into a plain Postgres SQL database, you are going to be managing table partitions and writing custom index maintenance scripts within a week. That is not where you want to spend your time. TimescaleDB works on top of PostgreSQL as an extension and automatically handles all the time-based partitioning behind the scenes. We can try Tiger Cloud free with link in the description. From my link, you can get $1,000 in credit for 30 days. And there is no credit card required. You can provision a database in under 2 minutes. So you can build whatever you want with this free credit, and there are no strings attached for newly created accounts. Let me show you how fast the provisioning is. So you can just create an account. So I've already created this account and I got this $1,000 available. So first thing that you need to create is new service. So here you can select real-time analytics, and here you can choose whatever cloud provider you want and the nearest region. Save and continue. I'll use one CPU, 4 gigs of memory. That is enough for this. And because I'm using development, I'll just use that and save and continue. And here connection pooling, save and continue. And it will also show you what is it going to be charging. So create. So within few seconds you can see it will be provisioned. So once this is done, you just have to download this configuration. So if you download that configuration file, you will be having this .env file. So if you open that .env in a notepad, here you can see that full URL, and then you can see what is the password, username, database, host, port, everything you can find out here. And if you want to change the password, you can simply go to the overview, and here in the connection info, click on more details. So you can do this forgot password and you will be able to change your password and reset. And also you will be having so many details like what is the database name, host, port, username that you have to enter in pgadmin so that you can connect your database. So first I'll try to open pgadmin. So this is the pgadmin, and here you can click on this servers and right click and register a server. So here you need to create a name first, and under the connection you need to provide the host name. So you can go here and find the host name, paste it, you can click on save password and save. Now you can simply open the database and you can see TSDB is available, and now right click on it and create PSQL tool so that you can create the database. And to create the database, we also have used Claude. Using this prompt, it has created me 3 different SQL queries. So first one is to create sensor readings. So it has created with these 4 columns, and then we are going to create TimescaleDB hypertable. So we are going to convert this table into hypertable. So that is also done. And then create an index so that we can filter the zones based on time range queries. Now let's see if there is any kind of chunks that are available, because we haven't sent any data, so that is not available. Next is we have to create a backend code which subscribe to this MQTT values that we are sending. So all these values right now are reaching to MQTT broker, but nobody is subscribing to this data and sending it to the database. So for that we have to create another backend file. So here also I'll be using Claude to create that. So I provided this prompt to the Claude so that it will read 20 sensors and using this as a topic, and then it will be posting to Postgre DSN and MQTT broker. Everything values will be from env file like that. So this file also will be created inside this folder that we have created. So that would be MQTT subscriber. So I'll just open it with VS Code. So this is the code that was generated by our AI. So here you can see basically you will be having load.env, and you have to provide the name of your file that you have downloaded recently. And remaining things you can simply look, those are just SQL queries. So connecting to MQTT broker and pushing into the PostgreSQL. Very simple code with a simple AI prompt. So now we'll just run this. We have to activate the Python virtual environment here. So I simply use this activate, and then if you run Python MQTT subscriber, you can see the data is coming continuously. So I'll just restart this simulation engine so that you can see the data from starting. So after 90 seconds, it is saying that zone C sensor 17 will provide an anomaly, that is it will be passing around 86 degrees Celsius. So now that we are pushing the data into the Postgres, I'll just show you from here. So I used select star from sensor reading order by time. So this is the latest values that you could see. So these are the values that are already being pushed into Postgres, that is TimescaleDB. So now that the ingest layer is working, we'll work on visualization layer. So that is Grafana. So for this, I'm going to use Grafana Labs, which is online version. So I'll just get started with free. So once you are inside, you can just launch your instance. So it will just take few minutes to get inside, and this is the home page that you will be available. So sometimes the Grafana is complicated for the beginners. So here also we'll be using AI for creating the configuration so that the dashboard will be created based on our prompt. So here I'll just show you what is the prompt. So this is the simple prompt where I am asking for 3 panels. So first panel is all zones temperature, and what is the query it has to use, even that select query I have given. So in the panel 2, it has to only show zone C because we are interested in the sensor 17 and it will be shown in red. So in the panel 3, you can see we are counting the threshold values and the alerts that are exceeding 86 degrees. So once you run this, you will be getting a JSON file. So the JSON file would be looking like this. So now, because we have this ready-made JSON to create a dashboard, so we'll simply go to Grafana and go to dashboards, and from the top you will be able to create new, and inside that import a dashboard, and here you just have to upload the JSON file. So this is the name I'll be providing. So to create this data source, you just have to go here and configure a new data source, and here you just have to type Postgres, and in the host URL, database, all these things you can fill from the Tiger Cloud from here. So once that is done, you simply save and test. You can see database connection is okay. Now you will be able to see your data source here and click on import. And this is how you can see 3 panels. So within few seconds, we were able to create these panels. And if you see what is inside, you can click on edit. So here we are using time bucket function, which is the TimescaleDB native SQL function. So it is not a standard PostgreSQL. It groups your timestamp column into clean, fixed with intervals and plays perfectly with Grafana's time range filters. This is the kind of features that makes TimescaleDB the right choice for the workload rather than just any database that happen to be nearby. So immediately you should be able to see the values that are coming here. So here in the all zones live temperature, you can see different values, and for each sensor in zone C also you can see these values, and already you can see the alerts because it has passed 90 seconds. So what I can do is I can simply stop the simulator and restart the simulator engine. So first it will be less. Here in the sensor 17, you can see it is now in 77 degrees Celsius. So every 5 seconds, if we do the refresh, we'll be seeing all the data values coming, and these alerts will be slowly going off. So now you can slowly see this sensor 17 is breaking out from the normal values. So it is trying to create an anomaly. Now immediately it has passed 87 degrees Celsius. Now because of that, you can see alert are started, and here also you can see the red line, which is the threshold we have kept, it is crossing that. In a real manufacturing plant, any operator with this dashboard open sees the moment it happened. No spreadsheet, no paper log, and no delay. You can also get notifications using Grafana alerting systems. So you can go to alerts and create alert rules and then try to send data to email, Telegram, etc. That is the complete pipeline. One real ESP32 sensor on physical hardware, 19 hardware in the loop simulated sensors, validating the full scale. Tiger Cloud absorbing 1.73 million rows per day without any manual partition management. And a Grafana dashboard that catches the anomaly in real time the moment it crosses the threshold. All the code for this project, including the firmware, backend codes, Grafana dashboard JSON, and every prompt I used with Claude is in the GitHub gist linked in the description. Pull it, run it, and make it your own. If you found this video informative, please type helpful and smash that like button. If you wanted to learn IoT from scratch, then you can check out my course on Udemy from the link in the end screen and description. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.